In 1712, a British ironmonger named Thomas Newcomen built a strange hissing machine of iron and wood beside a flooded coal mine in Staffordshire, England. It used fire to boil water into steam, and steam to move a piston, and that piston to pump water out of the mine so miners could keep digging deeper for more coal. It looked, to most people who saw it, like an oddity, a noisy curiosity built to solve one narrow problem. It was not a curiosity. It was the first practical steam engine in human history. And within a century, machines descended directly from it, would power factories, trains, and ships across the entire planet, all of them burning the same black rock that Newcomen's engine had been built to dig up in the first place. That rock did not just power the Industrial Revolution. In a very real sense, it was the Industrial Revolution, and its story is far older, far stranger, and far darker than most people ever learn. But coal's story does not start in a Staffordshire mineshaft, or in a Manchester textile mill, or on the deck of a steamship. It starts 300 million years ago, in a swamp, during a geological period scientists now call the Carboniferous, meaning literally coal-bearing. Much of the Earth's land surface, including what would eventually become Britain, Appalachia, and northern Europe, was covered in vast, humid, tropical swamps, dense with towering primitive trees, giant ferns, and plants unlike anything alive today. When these plants died, they fell into stagnant, oxygen-poor swamp water, which slowed their decomposition to a crawl, layer after layer, piled up over millions of years, compressed under their own weight, and later buried beneath sediment, until heat and pressure, deep underground, slowly transformed that ancient plant matter into a dense, combustible black rock, packed with the concentrated solar energy that those long-dead plants had once captured from the sun. Coal, in other words, is not really a rock at all. It is fossilized sunlight, 300 million years old, waiting patiently underground for something to come along and burn it. For most of human history, that is exactly what coal did. Nothing. It sat underground, undisturbed, while humans burned wood, dung, and peat instead. But in a few scattered places around the world, coal occasionally pushed up close enough to the surface that early humans stumbled onto it by accident. Archaeologists have found evidence that people in what is now China were burning coal for heat and cooking as far back as 6,000 years ago, making it one of the earliest documented uses of the fuel anywhere on Earth. The ancient Chinese also appear to have been the first to use coal, industrially employing it to smelt copper by around the 4th century BC. According to archaeological finds, centuries before coal use of any kind became widespread anywhere else in the world. In Britain, archaeologists have found evidence that Roman occupiers arriving around the 1st century AD discovered natural coal outcroppings and began mining and burning it, primarily to heat military garrisons and public baths in the chilly, damp province they called Britannia. When the Romans withdrew from Britain in the 5th century, this practice mostly faded away, and coal mining on the island went dormant for hundreds of years, remembered mainly through the ash and cinders. Later archaeologists would find buried beneath abandoned Roman forts. Coal re-emerged in England around the 12th and 13th centuries, when residents of coastal towns began collecting lumps of it that had eroded naturally out of exposed coastal cliffs and washed up along the shoreline, particularly around the northeastern English city of Newcastle. Because so much of this early coal was gathered from beaches rather than dug from mines, the English called it sea coal, a name that stuck for centuries, even after underground mining became the dominant method of extraction. For a long time, sea coal remained a marginal, somewhat undesirable fuel, associated with the poor, and used mainly by blacksmiths and lime burners, whose work required intense heat that ordinary wood fires struggled to produce. Wealthy households, and much of the general population, still overwhelmingly preferred wood, which burned cleaner and produced far less of the acrid, sulfurous smoke that coal was already notorious for. Even in the medieval period in 1306, King Edward I of England, responding to public complaints in London about the choking smoke produced by sea coal fires, issued a proclamation restricting its use in the city, one of history's earliest documented attempts at air pollution regulation, and, according to some chroniclers, at least one blacksmith was reportedly executed for defying the ban and continuing to burn coal illegally, an extraordinarily severe punishment that reveals just how seriously medieval authorities took the smoke problem, even centuries before anyone understood the health consequences we now associate with fossil fuel pollution. There was a problem, though, and it was a problem that would eventually force all of England toward coal, whether people wanted it or not. England's forests, which had supplied wood for heating, cooking, shipbuilding, and iron smelting for centuries, were disappearing. Population growth, agricultural expansion, and the enormous wood demands of a growing navy and iron industry combined to strip much of England's woodland bare by the late 1500s and 1600s. Timber prices rose sharply as accessible forests thinned out, and English households and industries alike were forced to look for an alternative fuel source, whether they wanted a smoky, sulfurous option or not. Coal, sitting abundantly beneath much of England's soil, particularly around Newcastle, Wales, and the English Midlands, was the obvious answer. By the 18s, English coal production had begun climbing steadily, and London in particular grew so reliant on coal shipped down the coast from Newcastle that the phrase "carrying coals to Newcastle," meaning to do something pointless because a place already has an abundance of that exact thing, became a common English idiom, one that is still recognized today, even though Newcastle's collieries closed decades ago. This is the part of coal's history that most people never learn about, and it is the part that would eventually trigger the single most consequential economic transformation in human history. As English coal mines expanded through the 1600s and into the 1700s, miners ran into an unavoidable physical problem. The easiest, shallowest coal deposits near the surface were quickly exhausted, forcing mining operations to dig deeper and deeper underground in pursuit of more coal. But the deeper a mine went, the more it flooded with groundwater, and by the early 1700s, some English coal mines were becoming so waterlogged that teams of men and horses working buckets and pumps around the clock could barely keep the shafts usable at all. Mine owners needed a mechanical way to move enormous volumes of water out of deep mine shafts faster than human or animal labor alone could manage, and that need is precisely what drove Thomas Newcomen to build his atmospheric steam engine in 1712. Newcomen's design was crude and staggeringly inefficient by later standards, but it worked well enough to pump water out of flooded coal mines faster than anything that had come before it. And within a few decades, hundreds of Newcomen engines were installed at coal mines across Britain, most of them, notably, burning coal themselves to generate the steam that powered them, a fuel feeding the very machine built to extract more of that same fuel. It was a Scottish instrument maker named James Watt, who, in the 1760s and 1770s, dramatically improved on Newcomen's original design, introducing a separate condensing chamber that made the steam engine roughly 5 times more fuel efficient and, crucially, adaptable to far more than just pumping water out of mines. Watt's improved steam engine, patented in 1769, and refined over the following decades, in partnership with the manufacturer, Matthew Boulton, could be configured to turn a rotating shaft, meaning it could now drive spinning machinery, weaving looms, and, eventually, the wheels of a locomotive. This single innovation is widely regarded by historians as the true ignition point of the Industrial Revolution. Suddenly, factories no longer needed to be built next to rivers to harness water wheel power. A factory could be built anywhere, in any city, as long as it had a reliable supply of coal to burn. And English cities like Manchester, Birmingham, and Sheffield exploded into dense, coal-blackened industrial centers almost overnight by the standards of previous centuries. Their factories running steam-powered looms and machinery around the clock, their skies thickened with a permanent haze of coal smoke that visitors from the countryside described as turning daylight itself a dim, sickly gray. Coal did not just power factories. It transformed how humans and goods moved across land entirely. In 1804, a Cornish engineer named Richard Trevithick built the first working steam locomotive, and by 1825, English engineer George Stephenson had opened the Stockton and Darlington Railway, the world's first public railway to use steam locomotives, hauling both coal and, soon after, passengers. Stephenson followed this in 1830 with the Liverpool and Manchester Railway, widely credited as the first railway built specifically for practical, high-speed intercity passenger and freight transport, and it triggered a railway-building frenzy across Britain, then Europe, then North America, that reshaped the geography of entire continents within a few decades. Railways needed enormous quantities of coal to run their locomotives, which further drove coal demand upward, which in turn justified building even more railways to transport that coal to cities and factories, faster than horse-drawn carts ever could. A self-reinforcing cycle of extraction and infrastructure that historians sometimes call the coal and iron economy, in which coal, iron, and steam power fed each other's growth in an accelerating loop that had no real historical precedent. But behind this explosive industrial growth was a human cost, every bit as brutal in its own way as the plantation labor that had defined sugar, coffee, and pepper. British coal mines in the 18th and 19th centuries relied heavily on child labor, with boys as young as 5 or 6 sent underground to work as trappers, sitting alone in total darkness for up to 12 hours at a stretch, opening and closing ventilation doors each time a coal cart needed to pass through. Older children and women were frequently employed hauling coal carts through tunnels too low and narrow for adult men to move through easily, crawling on hands and knees while dragging heavy loads by chains fastened around their waists. Parliamentary investigations in the early 1840s, prompted by growing public outrage, documented these conditions in graphic detail, including testimony from child mine workers describing injuries, exhaustion, and psychological trauma from years spent in near-total darkness underground. The resulting public scandal led directly to the Mines and Collieries Act of 1842, which banned women and girls, along with boys under the age of 10, from working underground in British coal mines. One of the first significant pieces of labor protection legislation in modern industrial history, though enforcement remained inconsistent for years afterward, and similar reforms elsewhere in the industrializing world often lagged decades behind Britain's. Even for adult miners, coal mining through the 19th and much of the 20th century remained one of the most dangerous occupations in the industrialized world. Underground explosions caused by flammable methane gas, which seeps naturally out of coal seams, killed miners by the hundreds in single incidents with grim regularity across Britain, the United States, and continental Europe. Coal dust itself, inhaled over years of work, caused a chronic and often fatal lung disease that became known as pneumoconiosis, or, more commonly, black lung disease, which left generations of retired miners gasping for breath in old age if they survived long enough to retire at all. These dangerous, grueling conditions, combined with often exploitative pay and company-controlled housing in mining towns, fueled some of the most significant labor organizing movements in modern history, including the formation of powerful mining unions across Britain, the United States, and Germany through the late 1800s and early 1900s, unions that would go on to play outsized roles in national labor politics for generations, sometimes bringing entire national economies to a standstill through large-scale strikes, as Britain experienced most dramatically during the 1926 general strike, and again during the extended miners' strike of 1984 and 1985. As coal-fired steam power spread from Britain across the industrializing world through the 1800s, it fundamentally altered the balance of global economic and military power in a pattern that echoed how control over sugar, coffee, and pepper had once reshaped earlier centuries. Nations with abundant, accessible coal reserves, chiefly Britain, Germany, and the United States, industrialized fastest and gained outsized economic and military advantages over nations without similarly accessible coal deposits. Coal-fired steamships gave European naval powers unprecedented range and speed, a critical factor in the aggressive colonial expansion that Western European empires pursued across Africa and Asia during the late 1800s. Since steamship engines dramatically reduced dependence on unpredictable wind patterns that had constrained naval movement for centuries beforehand, by the late 1800s, Coal had also become the primary fuel generating electricity, following the opening of the world's first central coal-fired power station by Thomas Edison in New York City, a one Bivan Basharar, an innovation that, within a few decades, made coal not just the engine of factories and trains, but the invisible fuel behind electric lighting, streetcars, and eventually household appliances across the rapidly electrifying cities of the industrialized world. Coal's strategic importance became starkly clear during both world wars of the 20th century, when coal-fired industry, coal-powered naval fleets, and coal-derived synthetic fuels became central to military production capacity on every side of both conflicts. Nazi Germany, cut off from reliable access to petroleum through Allied blockades during the Second World War, invested heavily in a chemical process for converting coal into synthetic liquid fuel, allowing German tanks, trucks, and aircraft to keep running for years on fuel refined not from oil, but from coal, a scientific achievement that likely extended the war's duration and reveals just how deeply coal remained embedded in industrial and military capacity, a full 2 centuries after Newcomen's original mine-pumping engine. The mid-20th century marked coal's peak influence over the global economy, but it also marked the beginning of its long, gradual decline. In the countries that had industrialized earliest, cheap and increasingly abundant petroleum, along with the post-war expansion of natural gas pipeline networks, offered cleaner burning, easier to transport alternatives for heating, transportation, and eventually electricity generation across much of the industrialized West. Britain, the nation whose coal had quite literally powered the birth of industrial civilization, saw its coal industry shrink dramatically across the second half of the 20th century, culminating in the closure of its last deep coal mine at Kellingley Colliery in North Yorkshire in December 2015, an event widely covered by British media as the symbolic end of an industry that had defined entire regions of the country for more than 2 centuries. Yet even as coal's dominance faded in Britain, the United States, and much of Western Europe, global coal consumption did not shrink to match. Instead, it shifted geographically, following the same pattern of relocated industrial demand that had once carried sugar production from the Caribbean toward Brazil, and pepper cultivation from India toward Vietnam. Today, China and India together account for the overwhelming majority of global coal consumption, using it primarily to generate electricity for their rapidly growing economies and expanding urban populations, a dependence that has made coal one of the most consequential and controversial subjects in modern climate policy. According to data compiled by the International Energy Agency, coal remains the single largest source of global electricity generation and, correspondingly, the largest single source of energy-related carbon dioxide emissions worldwide, making the fossilized swamp forests of the Carboniferous period, buried 300 million years ago, directly responsible for a substantial share of the greenhouse gas emissions now driving modern climate change. This has placed coal at the center of a global energy transition debate unlike anything in its long history. Dozens of countries have pledged to phase out coal-fired power generation entirely in the coming decades under international climate agreements, and the cost of solar and wind power has fallen so sharply in recent years that, in many parts of the world, building new renewable electricity generation is now cheaper than building or even continuing to operate existing coal plants. A genuine economic reversal that would have seemed unthinkable to the industrial planners of the 19th or even mid-20th century, who assumed coal's cheapness and abundance made it functionally permanent. Coal's story spans 300 million years, 6 continents, and nearly every major turning point in the transition from an agrarian world to the industrialized, electrified world we live in today. It was there, silently, for hundreds of millions of years, compressing in ancient swamps long before a single human being existed to burn it. It was there when Roman soldiers heated their garrisons on a damp, distant island at the edge of their empire. It was there when a London king banned its smoke, and a blacksmith was executed for defying him. It was there when English forests ran out and an entire nation was forced underground. In search of an alternative, it was there, most consequentially of all, in a leaking Staffordshire mine shaft, when a machine built simply to pump water became the spark of the Industrial Revolution. It was there in the lungs of children who spent their entire childhoods in darkness, and it is there now, in the debates of climate summits and energy ministries, in the slow, contested shutdown of the very industry it once ignited, 300 million years after it first began, quietly forming one dead swamp leaf at a time. A black rock formed from ancient swamp forests became the single most consequential fuel in the history of human civilization. It built factories. It laid railways across continents. It armed navies and powered empires. And it is now, for the first time in 3 centuries, being deliberately extinguished by the very civilization it helped build. And somewhere beneath the ground, right now, more of it sits exactly where it has sat for 300 million years, patient, dense, and quietly waiting, the way it always has, in the dark.